Alrighty, so welcome guys. In this video, we're going to be talking about how to do a proof of a quadrilateral on a coordinate plane. So the first thing, in order to feel comfortable with doing these, you need to feel comfortable with the different types of quadrilaterals that you can have. So this is something that you should have seen before, um, and it just kind of breaks down the different types of quadrilaterals. So first off, we can just have a general quadrilateral, which is any four-side polygon. So if, as you're trying to classify them, it doesn't fall into any of these other categories, then we would just say it's a general quadrilateral. But then we have some special types of quadrilaterals. So we can break them down into parallelograms, which I can highlight all of these in blue. Get a bigger one here. So all of these arrows are going to bring us into different types of parallelograms. We could have a kite, or we can have trapezoids. And inside of trapezoids, we have another special type of trapezoid. So we can fall into one of these three special types of classifications. The things that separate a parallelogram from a kite from a trapezoid is how many parallel sides they have. So for a parallelogram, they have two sets of parallel sides. That means both sets of opposite sides are parallel to each other. You can see that marked here with our different triangles, our different arrows. So for a parallelogram, both sets of opposite sides are parallel. For a trapezoid, only one set of the sides are parallel. So here, the top and the bottom one are parallel. For a kite, none of them are parallel to each other. So that's really the first thing that separates us. Inside of a parallelogram, we can go into more detail. After we decide that both sides are parallel, both sets of opposite sides are parallel, the next question we can ask are the angles 90 degrees? If the angles are 90 degrees, as we can see here for these pink right angles, that means that it's a type of rectangle. If the answer to that is no, then it might just be a parallelogram, or you might get a rhombus. So that's the next classification for a parallelogram, are the angles 90 degrees. If the angles are 90 degrees, you have a rectangle. Rectangles can be more specific by having all four sides be the same. So not only are these two parallel and these two are parallel, all four are the same. That's going to give us a square. Over here in the world of rhombi, if all four sides are the same length, but the angles are not 90 degrees, then we have a rhombus. So a square is the most special type of parallelogram because it is both a rectangle and a rhombus, and that gives us a square. If we come back over here to trapezoids, remember trapezoids, they said only have one set of parallel sides. If it just has one set of parallel sides, that's it. We can just call it a trapezoid. But there's also one special type of trapezoid, which is an isosceles trapezoid, which is saying, hey, not only is the top and bottom parallel to each other, the two sides are the same exact length. And then the last special one is a kite. Kites are really interesting. They do not have any parallel sides, but the consecutive sides or the adjacent sides are the same length. And so that would be that this side here and this side here, we can see that by the double orange dashes. Those two are the same length, and then these two are the same length. Noticing on our shapes here, this kite looks really similar to a rhombus, but it's not. They're not the same shape because for a rhombus, remember the two sides, the opposite sides have to be parallel to each other. A kite has no parallel sides. So once we feel comfortable with the different types of parallelograms that we have, those same kind of questions that I was asking, or those same different classifications, it's what's going to help us be able to find how to do a really good proof. So a proof would be me saying, I have four shapes and I know it's a rhombus because, and we can go through and prove that it's a rhombus. So you can see these are the examples that we'll get through before we're completely done with today's lesson. The way that we can determine this is using what we call the quadrilateral proof flowchart. Now, there are other classifications for each of these shapes. As you were looking at the flowchart I just showed you, you saw things about diagonals and perpendiculars and things like that. And if you look other places, you might find other ways to classify your different shapes. However, for the sake of our class, we decided this is pretty much the easiest way to always make sure you're definite. You've definitely shown what type of shape it is. So when we're doing a proof, so once again, we're actually going to be saying it is a very specific shape. the very first thing we always want to say is, are the opposite sides parallel? And we actually determine that by using the slope. So we'll be using the slopes to determine, are the opposite sides parallel? And you have choices there, and we can kind of classify those like we just saw. Either yes, all of the opposite sides are parallel. Let's see, I can use the colors I was just using. Only one side of opposite sides are parallel, or no, they aren't parallel. Those are your three options there. From there, you're going to see that you have different types of questions going off of it. We'll start on the right-hand side because it's the least amount. So if none of the sides are parallel, we only have two options. Either it's going to be a kite or it's just a basic quadrilateral. The difference there is, are the consecutive sides congruent? And we need to use the distance formula. Anytime we're talking about congruency with length, we're going to use the distance formula there. So this is how we would separate it. And keep going. We said that a kite, we were kind of using this orange color. So for the kite, we would say yes, the opposite sides, or not the opposite, sorry, consecutive sides are congruent. If the answer to that was no, we would just say, hey, it's a basic quadrilateral. And so for the trapezoids, we said a trapezoid, once again, only one side of it is parallel. Then we know it's a trapezoid. But the next thing we can do is just say, hey, is it a special type of trapezoid? We determine that by saying, are the legs congruent? If the legs are incongruent, then yes, it's an isosceles trapezoid. If the legs aren't congruent, it's just a normal trapezoid. But we'd have to work ourselves all the way down to the bottom here before we were done with our proof. For a parallelogram, it's a little bit more complex. So we have four different options that we can do. So because we just used the slope to determine if the sides are parallel for a parallelogram, we're going to use that again to determine, are the angles 90 degrees? So remember, we know that angles are 90 degrees if they're perpendicular. So we're just going to compare those again. If the answer is yes, we know we're in the world of a rectangle. It's either going to be a rectangle or a square if they're 90 degrees. So the next question, and this is actually the same here, whether it's yes or no, the classification is just different. Are all four sides congruent? And we'd use the distance formula there. So 90 degrees, all four sides congruent, it's a square. 90 degrees, not all congruent, it's a rectangle. Not 90 degrees, but all four sides are congruent, we have a rhombus. Not 90 degrees, not the same, it's just a basic parallelogram. So here you have it. We have 1, 2, 3, 4, 5, 6, 7, 8 possible different shapes. In order to do a full proof, you need to follow the lines all the way down until you get to your shape. And we're actually going to be using math to figure that out. So on this exact video, I've just kind of talked to you guys a lot. I'm going to do one example, and then we'll have two other example videos as well. So I'm going to step you guys through this one completely. So here we were given some points. I've already got my shape drawn for you guys. So we had points 3, 7, 7, 1, negative 2, 5, negative 6, 1. And I just went ahead and labeled them A, B, C, and D. You can label them whatever you want, but you do need to have them labeled so we can talk about the sides. Now looking at this shape, my gut reaction is it's a rectangle. I almost said parallelogram. My gut reaction is it's a rectangle. But the one thing we can't ever do in math is just say, well, it's a rectangle because it looks like it. In order to get to a rectangle, I have to follow this entire line. I have to show that, yes, the opposite sides are parallel. Then I have to show, yes, the angles meet at a 90-degree angle. And then I also have to show, no, all four sides are not congruent. I have to show all of these things in order for me to say with confidence that it's a rectangle. So let's see if that actually happens. So let's first start with seeing, are the sides parallel? So in order to do that, we know that for parallel means equal slopes. The slopes are perfectly identical. So I'm going to compare them. And we're talking about opposite sides, so I want to compare AD to CB. So those are the ones I'm going to try first. So the slope of AD is going to be that change in y. So I'm going to do my slope A, which is 3/7, or 3,7, 7 goes on top, minus D, so 1 over negative 6. I want to see, is it parallel to CD, so I'm also going to do the slope of CB. So yes, they are parallel. But notice that we have to show that both of them are. If it's just one, it might be a trapezoid. So I also have to show that DC and AB are also parallel. That blue did not show up well, but I promise I did put a blue line there. So that's what we're going to try now. So I'm going to find the slope of CD, doing the same thing here. And the slope of AB. -3/2, -3/2, yes, those are parallel. So what we have shown here, if we go back to our flowchart, is we have done this first part. We have said, are the opposite sides parallel? Yes, CD and AB are parallel, and yes, AD and CB are parallel. So we have followed this category, and we're going to keep going here to ask the next question. So with a really good proof, I'd actually go ahead and write a statement here in words. Both sets of opposite sides are parallel. Therefore, this quadrilateral is a type of parallelogram. But notice I wouldn't just stop here because I'm not done. I still have more questions to ask. So following my flowchart, the next question I'm going to ask is, are the angles 90 degrees? Well, 90-degree angles really just mean that the lines are perpendicular. So I would look at this corner here. The two sides that are coming in together are AD and AB. So I need to compare the slope of AD compared to the slope of AB. That's going to determine if this is a 90-degree angle. Well, I already have that above. AD is 2/3 and AB is -3/2. Well, you know what? Yeah, that is perpendicular. I know it's perpendicular because this one's positive, this one's negative, that's an opposite, and they're reciprocals of each other. So, hey, this angle is perpendicular. Or sorry, this angle is 90 degrees because these two lines are perpendicular to each other. Let's also compare, no, let's do DC as well. We always want to check at least two of them to make sure that we weren't just lucky there. So let's check this one as well. So we're going to do the slope of AD versus the slope of DC. Once again, AD we had, which is 2/3. And DC, same thing as CD, which is -3/2. And once again, yes, they are perpendicular. So if I were to add a sentence here, I would say the slopes of the intersecting lines are opposite reciprocals, which mean the angles are 90 degrees. That means this parallelogram is a type of rectangle. Now, some of you guys might think we're done there, because we have found out that yes, it is a parallelogram. Because the angles are 90 degrees, yes, it is a type of rectangle. And we said this looks like a rectangle. But if we come back to our flow chart, so we've gone here, notice we're not actually all the way down yet. Not only do we have to prove that it's a type of rectangle, we have to prove that it's not a square. And some of you are going to just say, well, obviously it's not. Those lines don't look the same length. But we always have to prove that. We're not done until we get to the very bottom. So our next question is simply, are all four sides congruent? Now, we can actually go really easily here. The two sides that I'd be comparing would be AD and AB, or CD and CB. Because we know, because it's a parallelogram, we know AD and CB have to be the same length. Because it's a parallelogram, we know CD and AB have to be the same length. The only question is, are the two side by side the same length? So I'm just going to do the distance formula for AD and the distance formula for AB. So my change in x here is going to be 3 and -6, which is 9. My change in y is going to be 7 and 1, which is 6. Let me find my calculator. Don't feel like doing that in my head really quickly. 81 plus 36 is 117. So now we're also going to compare that to, so we just did AD, we want to compare that to AB. My change in x is between 3 and 7, so that's 4. My change in y is between 7 and 1, so that's 6. Immediately, I can actually see that it was both 6 squared, but 9 squared versus 4 squared, which is in the same. But I'm going to go ahead and finish that all the way out just to show it to you guys. And we have 117 and 52. Square root of 117 is square root of 52. Those are obviously not congruent. They're not the same. So my last statement would be, because all four sides are not the same length, this is not a square. Therefore, final conclusion, this is a rectangle. So this is how we can do a really good in-depth proof. Once again, really using this flow chart, you want to take it all the way down. And so here we did take it all the way down to, it is a rectangle for that last shape. As you guys saw, I have 2 more of these. I'm going to do those in separate videos so that you can come back and watch them. I recommend trying to do these on your own first. So looking at them, trying to figure out what shape you think it is and doing a good proof, and then going and watching the video that I post.